Okay, we are now ready to move on from tau equals I alpha to energy ideas. So the first thing we'll do is we'll define rotational kinetic energy. Okay, so consider once again some axis. Okay, and let us say that we have a bunch of particles that are moving, constrained to moving around a circle with the same angular velocity. So this could be just particles of an object. Let's say it could be a baseball bat that's broken up into various little pieces, and they're all moving about the origin with the constant angular speed. Okay, let this distance be r1, the mass be m1, some other object of mass m2 with some distance r2, a third one here, distance r3, and mass m3. Okay, now we know that they all have the same omega, so therefore we know that their velocities, okay, we can calculate. So this will be v3, this guy will be v1, this guy will be v2, and we know the relationship between the velocity and angular velocity. We know that is equal to v. That relation is v equals r alpha, r omega. So now that we have all these pieces, we can calculate the kinetic energy. The kinetic energy for each of the particles is 1/2 m1 v1 square plus 1/2 m2 v2 square plus dot dot dot. Okay. And now I can replace v1 with r omega or r1 omega. So you get 1/2 m1 times r1 square omega square plus 1/2 m2 times r2 square omega square, and so on. And what this does is, you see, I can simplify this and rewrite this as 1/2. I can factor the half out and also the omega square out and write this. And we at this point recognize that the term in parentheses is simply our moment of inertia. And so we know that our rotational kinetic energy is simply 1/2 I times omega square. Okay, so the rotational kinetic energy is 1/2 I omega square. And if you see, it is similar once again to the translational kinetic energy of 1/2 mv square. We're replacing m with I, v with omega, which seems to be the theme. Okay. F was equal to ma here, but in the rotational we have tau equals I alpha. So we replace m with I and a with its angular part. Okay, so we got all these little pieces here. Now, in the next video, we will apply the concept of energy and rotation and everything to problems.